Hello everybody and welcome to video number 3 on naming compounds. Today we're going to talk about covalent compounds, which I think you will find much easier than ionic compounds. So here we go. For this lesson you will need a piece of paper, a pen or a pencil, and your periodic table. Your polyatomic ion chart will also be helpful because it has the prefixes listed on it. So pause this video now to make sure you have everything you need. Press play when you're done. Okay, welcome back. Okay, so what are covalent compounds? Just some review. Remember, it is when you have a nonmetal bonded with a nonmetal. They have covalent bonds. A covalent bond is when electrons are shared between two elements. So it looks like this. Look at those nonmetals sharing their electrons. Okay, let's write the names. So the name of a covalent compound has the first element is written first, the second element is written second, and it has its ending changed to IDE, just like in ionic ones. So you're going to write them just in the order that you see them. And we use prefixes to tell how many of each molecule we have. I'll show you what those prefixes are in a moment. One note about this, though, is that the prefix mono is only used on the second element in the name. You don't put mono on if you only have one of whatever the first element is. I don't know why. Scientists are weird sometimes. So here are your prefixes. So when you have one of something, it's mono. Again, don't use that on the first element in the compound. 2 is di, 3 is tri, 4 is tetra, 5 is penta. Those are the most common ones, but you can go higher than that. 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, and 10 is deca. So you'll notice that there's a chart like this on your polyatomic ion chart that you can use to help you. You don't have to memorize them. Okay, so let's give some examples a try. So here you have CO. So you have one carbon and one oxygen. So when you go to name it, you'll write the name carbon. And you might want to put a mono on there to show there's one carbon, but don't do it. Don't use mono on the first element. On the second one, however, where there's one oxygen, you are going to put mono. So this is going to become carbon monoxide. Have you heard of carbon monoxide before? Maybe you have a detector at home to see if you have carbon monoxide to protect you from carbon monoxide because it's a poisonous gas. CO2 is going to be, again, carbon, but now there's 2 oxygens, so that's going to become carbon dioxide. Carbon dioxide is much less poisonous. We breathe this out. However, it is largely responsible for climate change. Pi3, we have 1 phosphorus and 3 iodines. So this becomes phosphorus triiodide. Notice this double I in there. It looks kind of weird, but that's how we write it. And notice, too, that I'm changing the endings to IDE, just like I've been doing this whole time with ionic compounds. Next one is N2O4. So we have 2 nitrogen. Finally, we're going to put a prefix on our first element. So we have here dinitrogen tetraoxide. And P2O5 would be diphosphorus pentaoxide, penta for 5. Okay, you know the drill. Pause the video and try practicing on these 4 compounds. Press play when you're ready for the answers. Okay, welcome back. How did you do? CO3 is carbon trioxide. If you saw CO3 and you thought, oh, carbonate, this is different from carbonate because you can see here there's no ion charge. So this is not our polyatomic ion carbonate. This is actually a covalent compound called carbon trioxide. SO2 is sulfur dioxide. P3Br5 is triphosphorus pentabromide. And AS2S3 is diarsenic trisulfide. How did you do? Okay, now we're going to go on to writing formulas. This is my favorite thing to do because once you know what the formulas are for different elements, you don't even have to look at your periodic table anymore. You just use the prefixes in the name to decode how many of each element you have. So, for example, dinitrogen trioxide. You know that dinitrogen means you have 2 nitrogens. Trioxide means you have 3 oxygens. So your formula becomes N2O3. So notice that we have 2 nitrogens, so that 2 goes right with the nitrogen there. Don't do anything fancy like swapping those numbers or anything like that. It's just N2O3. Next one's sulfur tetrafluoride. So you're going to say, okay, sulfur is S, and there's 1 of them. Fluoride is fluorine, which is F, and there's 4 of them. So 1S, 4 Fs just becomes SF4. Okay, easy peasy. Here's oxygen difluoride. So oxygen has no prefix, so there's just 1 oxygen. Di means 2, so there's 2 fluorides. Becomes OF2. Okay, you try. Pause the video, give these ones a try, and press play when you are ready to see the answers. Welcome back. Here are the answers. Carbon tetrabromide becomes CBr4. Iodine monochloride becomes ICl2. Tetraphosphorus decasulfide becomes P4S10. Diboron tetrachloride is B2CL4.